All right. We have looked at using the law of sines for any triangle A, B, and C to find either a missing side or missing sides or a missing angle or missing angles as we've gone through. Now, I gave you some problems to try, and hopefully you tried them and got them right, but there are always, it takes more practice, and then you start to get more familiar with these things. Remember, the trick with the law of sines is you want to look at ratios. Sine of an angle to its opposite side is equal to the sine of another angle to its opposite side. And we have three angles and sides, so it can be any of those three angles with the opposite sides. And you can do the reciprocal side to sine of the angle as well. So if we look at this, when we first look at this problem, we want to solve for side x, okay? It's not a right triangle. We're not given enough information. Well, actually, we are given enough information. It's not a right triangle. If you don't have a right triangle, we don't use our trig ratios or Pythagorean theorem. But do we have an opposite angle side pair? We do. We have the side of 376 and its opposite of angle 98.4 degrees. So 376 centimeters. And so this is angle A, and this would be side A. We're wanting to find side that's labeled X. Notice X is the opposite of angle C. So angle C is the opposite of side C, which is the side X that I'm wanting to solve for. I need to know what angle C is in order to use the law of sines to find X. Do I have enough information to get angle C? I do. Three angles add up to be 180 degrees. So I can go 180 degrees minus this angle that we know, 24.6 degrees, minus this other angle we know, which is 98.4 degrees. And if you go 180 minus 24.6 minus 98.4, you get 57 degrees. So we know this angle is 57 degrees. Now we can use the law of sines to set up our equation. The sine of A is to side A. The sine of 98.4 degrees is to side A, which is 376 centimeters, as the sine of C, which is the sine of 57 degrees, is to side C, which is what we're looking for, X. So there's my setup with law of sines. Cross multiply. So I have X times the sine of 98.4 degrees equals 376 times the sine of 57 degrees. I'll divide both sides by the sine of 98.4 degrees. So I get X is equal to, go grab your calculator, make sure it's in degree mode, 376 times the sine of 57 degrees divided by the sine, be careful, that was sine of 98.4 degrees, divided by the sine of 98.4 degrees. And that is 318.75, etc. Now I was not told where to round. I always tend to go a decimal further. So I know that X is approximately 318. If I go to the 10th, that'll be a 0.8. 0.8, I do know my units here. The length of the side is in centimeters. Centimeters. Or if you're not told where to round, if you want to take it the same number of units as the original side, that's fine too. The whole number would have been approximately 319 centimeters. So there's our answer, okay, using law of sines. We'll work through a few here. Our second problem that said try, we were given a triangle ABC where angle A is 80 degrees. Side B, because it's opposite of B, this would be side B is 3.4 inches. The side opposite the 80 degrees, or angle A, is 6.5, so that's side A. And we don't have any other information. If you're asked to solve a triangle, look at what's missing. We don't know angle B, we don't know angle C, and we don't know side C. Those are the things we're looking for, okay? Do we have an opposite side and angle pair? We do. Right here, my A's are opposite. So I know that I have the sine of 80 degrees is opposite the 6.5 inches. Okay, so I have that. So I can go sine of 80 degrees is to 6.5 as. Now, what other information am I given? I know side B. So I could deal with sine of B over side B. I know side B is 3.4 inches. I don't know angle B. So that's just sine of B. There's my application of the law of sines. And we'll cross multiply. So this tells me that 3.4 times the sine of 80 degrees is equal to 6.5 times the sine of B. I'll divide both sides by 6.5. So that gives me the sine of B is equal to 3.4 sine of 80 degrees over 6.5. Okay. And remember, when you're solving for an angle, you use inverse trig functions. Since we have sine of B equals, that means angle B is going to be equal to the inverse sine of this fraction. Okay. Remember the thing about these. When you use your law of sines to find an angle, look for two possible cases to exist. This is going to be our first case. So if I go inverse sine of 3.4 times the sine of 80 degrees divided by 6.5, then I get, excuse me, 31.006, so on. So my first case, angle B would be approximately 31.0 degrees, okay? I could also have a case 2. Case 2, for angle B, take the supplement of this, 180 minus the 31.0. And that is 149.0 degrees, okay? So two possible cases, all right? So we could have angle B is 31 degrees approximately. And we could have that angle B is approximately 149 degrees. Let's see if they both hold up. What does that mean about angle C? We can get angle C by taking angle B away from 81 and angle A, which was 80 degrees, away from 180. So 180 minus the 31 minus the 80 is 69 degrees. So in this case, C is approximately 69.0 degrees. Let's check this case. Angle C would be 180 minus angle B minus angle A. 180 minus 149 minus 80 is a negative 49 degrees. You can't have a negative angle. Case 2 does not exist for this one. So we have angle B and angle C. I still need side C. So for side C, I'm going to use law of sines again. Well, what did I have to start with? I knew that the sine of A was to A, and I'm going to use sine of C is to C. Sine of A is sine of 80 degrees. Side A was 6.5 inches. C was 69.0 degrees. We don't know side C. So again, you can cross multiply. Divide by sine of 80 degrees on both sides. And we'll go 6.5 times the sine of 69 divided by the sine of 80, and we get 6.1618, so on. If I go to the 10th, that would be approximately 6.2. I did have units here of inches for my side, so C is approximately 6.2 inches. Remember your units. Angles were in degrees, so I used the little bubble degree symbol. Side was in inches, so I used inches as my units there. That was my only solution for this one. All right. Our third try problem. We had 4 in this section that we looked at. We want to solve a triangle. We weren't given the triangle itself, but we were just given some information. Angle A is 50, angle B is 68, and side C is 230. Well, if I look at this, I don't know anything. I know it's not a right triangle, so I can't use ratios. Do we have an opposite angle side pair? Not given, because I have angle A and angle B, and I don't have side A or side B. However, remember, if you know 2 angles, you're going to know your third angle. We can get C quickly. Angle C is going to be 180 degrees minus angle A, which was 50, minus angle B, which was 68. And it may have been just given as 68 at one point there. So let's see, 180 minus 50 minus 68 is 62 degrees. So we actually know angle C is 62 degrees, and we know side C. So we have angle C and side C, okay? So we can start with our law of sines. So the sine of angle C would be the sine of 62 degrees is to side C, which was 230, as. Okay, so I use the C's. I'm going to have to find both. What do I want? What's wanted here? I want to know what angle C is. I want to know what side A is, and I want to know what side B is. I've already found angle C. That was the quick one to get. Okay. I need side A and B. So I'm going to have to use my law of sines a couple of times here. I'll go ahead and think about my A's for a minute. So the sine of angle A would be 50 degrees. So the sine of 50 degrees is to side A. So we'll go ahead, we'll cross multiply. So that means you have A times the sine of 62 degrees is equal to 230 times the sine of 50 degrees. Get A by itself by dividing by sine of 62 degrees. So A is equal to 230 times the sine of 50 degrees over the sine of 62 degrees. So go into your calculator, do the calculations. Again, make sure you're in degree mode. And we get 199.5477, etc. I'll go to the 10th. So A is approximately 199.5. Do I know units? I don't. I don't know if it's inches, centimeters, whatever. So I'm just going to write it as 199.5. So I have angle C. I had side A. Let me do the same thing for side B. For side B. So I'm going to take what I know. Sine of 62 degrees is to 230. That's my C's. Angle C and side C. Okay. Now I need my B's. I know that angle B is 68 degrees. So I have the sine of 68 degrees is to side B. And I do the same thing. cross multiply. So I have b times the sine of 62 degrees is equal to 230 times the sine of 68 degrees. Whoops, degrees. Divide both sides by the sine of 62 degrees. So I have 230 times the sine of 68 degrees divided by the sine of 62 degrees. And that comes out to be 241.52, etc. So to the 10th, that's 241.5. So what we have for our solution for this guy, our final answer in here, is what did we need to solve? We needed angle C. Well, angle C is 62 degrees. We were able to get that directly just by subtracting angles. So we didn't estimate it. It was 62 degrees. Side A was approximately 199.5. I used approximate because I did round to the 10th. And side B is approximately 241.5. Again, I used the approximate because I rounded to the 10th. Notice I didn't have to look at different cases here. When I solved for the angle, I wasn't using law of sines to get that angle, okay? You only look at multiple cases when you're using the law of sines to get an angle. We didn't do that first here, okay? Let's look at our last try problem from this section. Again, we want to solve a triangle given the angle B is 25 degrees, side B is 25, and side C is 30. Notice right here, we have angle B and side B. So we do have an opposite side angle pair, okay? So I know by the law of sines, I know that I can write this as the sine of angle B, which is 25 degrees, is to side B, which is a length of 25, as, and I can have another fraction to help me get an equation started. What other information do we have than angle B and side B? We have side C. I know side C, so if I use angle C and side C, I know side C is 30. I did sides in the denominator. So my numerator for that would be the sine of angle C. I don't know angle C. So I'm going to use law of sines to get it. Again, I can cross multiply. So this says that 30 times the sine of 25 degrees would be equal to the sine of 25 times the sine of C. Divide both sides by 25. So that gives us the sine of C is equal to 30 times the sine of 25 degrees over 25. Now be careful here. There's a 25 here, there's 25 here. You can't cancel those out. That's not sine times 25. That's the sine of 25. Those two things are glued together. That's not multiplication. That 25 in the numerator is not a multiple. So no canceling out there, okay? So I can get the angle by going C is equal to the inverse sine of the 30, was that 30? Times the sine of 25 degrees over the 25, okay? So I grab my calculator. I do inverse sine of that whole fraction, 30 times the sine of 25 degrees divided by 25. And I get that C is 30.4736, so on. So I have angle C is approximately a 30.5 degrees. Remember notation. We used law of sines to get an angle. We used law of sines to get an angle. So that means you need to look at two possible cases. So case one is angle of C is 30.5 degrees. Case two is going to be that angle C is the supplement of that, 180 minus 30.5 degrees. So 180 minus 30.5 is 149.5 degrees. So we have two possibilities for angle C there, okay? Let's finish solving the triangle. What is it that we want? We were given angle B. So what are the things that we need? We need angle A, angle C, and we had sides B and C and side A, okay? I just found angle C for both cases. Once you know two angles, you can get the third. So angle A would be 180 degrees minus angle C and angle B that we were given. So we have 180 minus 30.5 minus 25. This would mean that angle A would be 124.5 degrees in this case. Let's look at the case over here. Here, angle A would be the 180 degrees minus angle C minus angle B. So in this case, we'd have 180 minus 149.5 minus 25. That's 5.5. It's positive. That's a very tiny angle, but it's still a very valid angle. So we now have angle A for each case. And then finally, you need to find side A for these. So what are we going to need for side A? We're going to need angle A so that we can have a ratio for the A's. And then since we had an opposite angle pair here, what I'm going to do in each of my cases is I'm going to take the sine of angle B to side B and set it equal to the sine of angle A to side A. For each case, I'm trying to solve for A. So in the first case, let me just look over here. In the first case, I'll have the sine of angle B, which is 25 degrees, is to side B, which was 25, as I know what angle A is now. The sine of 124.5 degrees is to side A. And again, I use law of sines, I can use cross multiplying and solve. I do the same thing over here. I'll use my B's. The sine of B is sine of 25 degrees, is to side B is 25, as the sine of angle A, which is 5.5 degrees, is to side A. And again, I'll cross multiply. So go through and solve each of those fractions. Let me go ahead and move this paper a little bit. So I cross multiply. A times the sine of 25 degrees equals 25 times the sine of 124.5 degrees. Divide by sine of 25 degrees. Okay. So we have 25 times the sine of 124.5. Divided by sine of 25. And we get 48.75, etc. So A is approximately 48.8. I don't know units, so I'm just going to leave it as 48.8. Do the same thing over here. So we have 25 times the sine of 5.5 divided by the sine of 25. And we get 5.669, so to the 10th. A would be approximately 5.7. So we have our solutions for both cases. Angle C is 30.5 with angle B of 124.5 degrees and side A of 48.8 units. Our second case is also a valid solution. Angle C is 149.5 degrees. A would be approximately 5.5 degrees and side A would be approximately 5.7. So this problem, we had two cases. So there are a few examples. Make sure you try your homework. Let me know, let a tutor know, let somebody know if you're still having some questions on those, but practice your homework, see how you do.